Welcome to lesson 10 and 11. Today we're going to be talking about domain and range. And in this conversation, we're transitioning out from before the mid-unit assessment and now talking about specific types and specific details about our function. So in the rest of this unit, we're going to be talking about different types of functions and how we can classify and understand more details regarding these functions. And so our goal for today is let's find all the possible input and output values of a function. So, vocabulary. Our domain of a function is a set of all possible input values. All possible input values are all my x-axis. And so for example, if I have the function sine of x, which is something we have not seen before, you'll see it in trigonometry. It is all values from 0 to 2 pi. So we're looking at all the values in my x-axis, or all values of my input. My range of a function is a set of all possible output values. And so for my range, I'm looking at all of my output values. And so looking at the graph of sine of x, we know that the graph goes from -1 on my y-axis to +1 on my y-axis. And so my range goes from -1 to +1. And so we're going to talk about multiple examples going through this lesson, and it's going to kind of be a topic that goes through both the rest of this mid-unit into the next unit, and when you get to Algebra II as well. So a couple other details when we're describing our domain. We're talking about the idea of an integer. We're going to upgrade our general understanding of a number. So when you are younger, you learn the idea of a natural number, and so that is your counting number. So we're starting off 0, 1, 2, 3, 4, 5. An integer is a whole number that can be positive, negative, or 0. So it is -1, -2, -3, 0, 1, 2, 3, right? So it's both the negative and the positive and including 0. A rational number is a number that can be expressed as a ratio between two whole numbers, and so which is a fraction, right, or a reoccurring or finite decimal. So our rational values include my natural numbers 1, 0, 1, 2, 3, my integer values -1, -2, -3, and my rational numbers 1/2, -2/3, 2.25, 7.75. So it includes my fractional values as well. Let's get into it. So today we're going to talk about a situation that we talked about earlier. Earlier, we saw a situation where the total number of times a dog has barked is a function of time in seconds after its owner tied its leash to a post and left. Less than 3 minutes after he left, the owner returned, untied the leash, and walked away from the dog. And so today, I want you to take a look at what could each value be an input of the function. The total number of times a dog has barked is a function of time. Time is my input. My output is a total number a dog has barked. So think about, could each value be an input of the function? Can I have 15 seconds? Can I have 84 and a half seconds? Can I have 300 seconds? For the second question, could each value be an output of the function? Can I have 15 total number of times a dog has barked? Can I have 84 and a half total times a dog has barked? Can I have 300 times a total number of times has barked? I want you to think about each of those possible values, and I want you to take a moment to explain whether you believe or don't believe that is the case. And so in our next situation, we're going to continue to talk about what is possible and impossible values. Decide whether each number is a possible input for the functions described here. Sort into two groups, possible inputs and impossible inputs. A tennis camp charges $40 per student for a full day camp. The camp runs only if at least 5 students sign up, and it limits the enrollment to 16 campers a day. The amount of revenue in dollars that the tennis camp collects is a function of the number of students that enroll. The equation R of n equals 40n defines this function. My n is my input. My input is a number of campers. My number of students that enroll. And so the question you want to be asking is, what values make sense in this situation? Can I have a negative number of students that enroll? Can I have a decimal or fractional number of students that enroll? Are there any other limitations that I see here? So those are the questions you want to be asking yourself. And so that will help you figure out which values are possible inputs and possible outputs, right? In this case, We have certain limitations as well. The camp will run only if at least 5 students sign up and limits the enrollment to 16 campers a day. So a possible zero cannot be a possible input because we need at least 5 students. And so zero is less than 5. So zero is an impossible input. And so I want you to take a moment to sort each of your values into possible inputs and impossible inputs. So in the end, my domain is considered all integers, right? Because in this case, when I have my number of students, can I have fractions? I cannot have fractions. I cannot have negative numbers because you can't have a negative number of students. You can't have a fractional value of students. And so we are talking about integers. Integers are positive or negative whole numbers. So in this case, we are all integers, all whole numbers from 5 to 16. So my domain here is all integers from 5 to 16. Right? Integers here means whole numbers. In the second question, we have a function representing the area of a square and the previous question, the revenue of a tennis camp. I want you to refer to description of these functions to answer the following questions. So here's a graph that represents function A defined by A of S equals S squared, where S is the side length of square in centimeters. You want to name 3 possible input-output pairs of the function. Use your graph to help you. Earlier, we can describe the set of all possible input values of A as any number greater than or equal to 0, right? We can look at the graph and see that we are starting at 0, right? I can have a side length of 0, and we go from 0 all the way up to any number that's greater, right? You can have a square that is 8 inches long, centimeters. You can have a square that's 20 centimeters long. You can have a square of 2,000 centimeters long. So my domain is any number greater than or equal to 0. And so the question is, how can we describe the set of possible outputs here? We start at what number and we go all the way up to what number? And you want to ask yourself, can I have an integer? Can I have a decimal? Can I have a rational number? Can I have a fraction? Can I have a negative number? And so I want you to answer the question below. How would you describe the set of all possible output values? The function r is defined by r of n is equal to 40n, where n is a number of campers. We just talked about this in the beginning. The next thing you want to ask yourself, is 20 a possible output value of the situation? What about 100? Here are 2 graphs that relate the number of students and camp revenue in dollars. Which graph could represent the function r? Explain why the other one could not represent the function. Describe the set of possible output values of r. So I want you to think for a moment. We are talking about our input values. What we decided is that our input values do not include decimal values, right? We only can have whole numbers of students. And for each student, it costs $40. So can 20 be a possible output? Can 100 be a possible output? I want you to think to yourself. And if you are stuck, create a little table for yourself, right? So if I have a table here for 5 people, we have 5 people, there's $40 per person, and it's going to cost $200. For 6 people, it's going to cost $40 per person, it's $240. For 7 people, it's $40 per person, it's $280. So you want to keep going, right, for each value that you have here. And so we go all the way up to 16 here. So for 16 campers, it costs $40 per person, and we have a value of 640. And so if I wanted to describe the possible output values of R, there's 2 ways you can do it. The first way, list all your values. Oh, I switched them. So the first way, in the brighter blue, list all your range values out. So you, in a little set notation, which is a little curly Q brackets, you want to list all the numbers that you have for your outputs. The other way you can do it is describe it in a sentence. The range is all non-negative integers. We're not talking about negative integers. The word non-negative means that that I am not including 0. Including 0, but not including negative numbers that are multiples of 40 from 200 to 640. As you can see here, every single number here is a multiple of 40, right? 40 times 5, 40 times 6, 40 times 7, 40 times 8, etc., etc. So all these are multiples of 40, and we're talking about the multiples of 40 that start from 200 and end at 640. And so these are 2 ways of describing the same range, and if you describe it either way, that either way works for me. Last but not least, a tennis ball is dropped from a certain height. It bounces several times, rolled along for a short period, then stopped. Function h gives a height and time. Here's a partial graph of h. Height is measured in feet and time is measured in seconds. I want you to use the graph to help you answer the questions below. Number 1 and number 2 are a review from lesson in 6 and 7. So if you need to go back and watch that video and figure out what those values are, go ahead and watch that video. 3 and 4, you want to take a look at your x and y values. Your domain of the function is all your x values from the beginning to where your graph ends. The range of your function in blue is your y values from where the graph begins to where the graph ends. And so I want you to tell me that the domain of the function is between 0 and 3.7, right? We see that we started 0 and we go to 3.7. And I want you now to tell me what the corresponding range of my function is. So my domain of the function in a full sentence is all numbers, because we can have fractional and decimal values, all numbers between 0 and 3.7. And so do the same thing for your range as well. And so, right, I can write it in inequality notation as well. So x is between 0 and 3.7. X is greater than or equal to 0 and less than or equal to 3.7. Last but not least, our learning targets. I know what it is meant by the domain and range of a function. When a given description of a function in a situation, I can determine the reasonable domain and range for that function. And so we'll talk about this more in next class, and I look forward to seeing you then.